Welcome to Spring LIB.
In this problem, we have a pulley here with a shorter, like a disc here with a pulley on it. That I mean, they're attached together, so they're welded together. There's a brake on this outer ring here. There's a weight wrapped around this whole system here. The radius here is didn't write that down. 250 millimeters. Okay. And so they tell us that the brake is released, so that goes away. So now we're no longer in equilibrium. So we have, in 4.5 seconds, this weight falls 5 meters. And it all starts from rest because we basically release the brake. Now, what happens here, so we have the force of the weight. I didn't really need to draw a free body diagram here because it's all just kinematics. But anyway, it's nice to have kind of a little sketch of all the forces acting. So I have the weight and then the friction force from the brake. But once the brake is released, and we have no longer have equilibrium. So we know that this thing is just falling linearly. So its displacement, its change is the if we take positive as down, is the initial velocity times time plus the acceleration times time squared. And the initial velocity was 0. So we can solve for A, and that winds up being 0.434 meters per second squared. So that's how fast this thing is falling. Now we have, yeah. Anyway, we have, then they ask us for the angular velocity of this pulley here. So that's just the velocity divided by the radius. So the angle is, so the velocity here. So again, this is the velocity at this point here. So that the radius we have to use is this radius, which is good because they didn't give us this radius. So the velocity is just the acceleration times the change in time. But in this case, they ask us the change in time is 3.5 seconds. So this is the angular velocity at 3.5 seconds. So we have all of these values here. So plugging everything in, and we get that the angular velocity is 6.91 radians per second, obviously in this direction. They ask us also for the angular acceleration of the drum. Well, that one's easy because that's just the acceleration of a point on this ring here in the tangential direction divided by the radius. So we can take this and divide by the radius, and we get 1.975 radians per second squared.